I would love to introduce our last speaker. Our friend Bradley is going to be talking about making your own controller. And when I say controller, I mean hardware. He's got a lot of interesting projects that he's worked on in the past, and you may have seen in the Discord recently, he's been sharing a lot about some of the cool things he's been working on. Is also tweeting a lot of really awesome pictures about some of the controllers he's made and what he's working on now. And he also has some resources that he will be able to share in the chat, and he'll be sharing throughout the presentation. So please welcome our friend Bradley.
Hi, my name is Bradley Elenbaas, and I'm going to give a presentation on building your own controller. This presentation ended up being a lot longer than I expected it to be, so I'm going to move pretty fast, I suppose. I just did a recording, and it was 40 minutes long. This is myself. My name's Bradley. Hi. I make installation pieces and controllers. I lived in Portland in the past. I don't live there anymore. I was a software hardware engineer, which is a fairly unique position, going from where I deal with everything from the physical layer through a networking layer to the end user, like making a GUI. In web stuff, this sometimes gets called full stack engineering. I don't really know what you call it in hardware space, so I call it a software hardware engineer. I don't have an engineering degree. I don't have a completed CS degree. I do have an undergraduate in English writing and about 9 years experience doing this specific kind of work now. About 9 years ago, I got hired as a technical writer and then became a programmer, and I suppose the rest is history. This is the controller. You can see it up in the upper right-hand corner. You might ask, why are you making a controller? Well, it's because I make installation pieces, but installation pieces don't communicate very well. This, when you see in the bottom right-hand corner, is great. It's huge. People love it, love looking at it. Nobody knows what they're looking at all. So I'm refocusing my energies to try to have a regular controller and have it communicate that like as best and as clearly as I can. I make dense installation pieces and other installation pieces. Tell your friends if you are interested in anything like this. So maybe you want to do this, but where do you want to? Where do you start? Start with a lexicon. Anywhere. You just need some words to start searching for things and being able to teach yourself a little bit. So you're going to want to know what an Arduino and a Raspberry Pi are, and they're two examples of embedded systems. Sometimes they're called microcontrollers, sometimes they're called boards for short. Like any good Dostoevsky novel, there's 3 different names for everything. So it's that's always very helpful to make things very unclear. Arduinos and Raspberry Pis are a lot like your regular computer. A Raspberry Pi even runs a regular operating system, regular Linux operating system, mostly regular. It's fine. It's pretty much the same thing. It's okay, you know. They're just edge computers, I suppose. The controller and an application will have a client-server relationship. The controller will be a client, and I'm going to use a Unity application as a server. Those relationships are a bit malleable. They can switch back and forth, certainly, but I'm using it very kind of strictly and simply. Where do you start? Get a breadboard. There's simple grids where the vertical columns are the electrical lines, and they let you organize things really easily while doing it all like without solder, so you can be really dynamic. Whenever you're done with that, you're going to want to finalize things with solder, and then along the way add an LED, add some buttons, add a joystick, add a battery, add a case. Oh yeah, it is really easy to ask some dumb questions. They're kind of smart questions, but there's a lot to this. So just if you're interested in it, just go for it. Like, just start anywhere. It's fine. Get an Arduino. Get a case. Arduinos are really tough. Buy some spare parts. Any parts you buy, maybe buy 2 or 3. It's not the cheapest. It's really not the cheapest hobby, so expect to drop a little bit of money right away. $100, $200 if you want to get really fancy. Always wear your PPE. Lead solder is lead. Wear your PPE. There's some other things if you want to move beyond the Arduino family. The Feathers, the Teensies, the Nanos, they're all great. There's some other microcontrollers. The Raspberry Pi is fantastic. Cypress has fantastic microcontrollers. They have a PSoC and Wicked boards that are both great. Here's some search terms. You might want to mix and match these if you're looking to do your own thing in the future. Look for Arduinos. Look for kits. Look for Arduino Adafruit kit, and you're going to start finding things. Adafruit makes kits. SparkFun makes kits. QN makes kits. They all make kits for the Arduino and Raspberry Pi. They offer documentation all the way through. Often they have video documentation. They have forums. DigiKey is a great source. C4 Labs makes a great acrylic case that are pretty affordable. Search for things that throw a hat or sandwich in the mix. A hat's set on top, sandwiches go on the top and bottom, but they're both general components. You might find a Arduino Wi-Fi hat or an Arduino IoT sandwich. Those are both products. If you look for those, I know you'll find something. Start by picking a microcontroller. I'm going to use this Feather board. The Feather is the family, and the model is like the Huzzah 32 ESP32. The full name is Adafruit Huzzah 32 ESP32 Feather. Great name. You can see some alternatives in there, certainly with the Pi and the Cypress boards. This Feather board's geared for Wi-Fi. It's great. That's why I'm using it. It has C++ libraries for UDP. It has a ton of analogs for joysticks. Every joystick you add is going to need 2 analog pins. And to put it into perspective, the Raspberry Pi doesn't have any analog pins. So, sweet. If you want to find the documentation on this board in particular, look up Adafruit Feather ESP32, and you'll find the Adafruit documentation, and it'll lead you to the repository as well. The controller is the client. What it does is it blasts out a UDP packet every 10 milliseconds. Going faster than that causes it to flood the output stream. So 10 milliseconds is as fast as I could get this particular microcontroller to send out UDP packets, though your mileage may vary. It's all C++, so there's some confusion about this with Arduino sometimes. It's kind of strange in the microcontroller world that it uses C++, because C++ has a huge standard library, and then that library is not included with the Arduino. Parts of it are, and then Arduino has its own library that goes on there, and it makes the conversation pretty confusing, especially since their documentation actually describes it as Arduino language, which it's not. It's C++. You know, different libraries, but same language. And it's not C. Most things do use C. Cypress boards use C. But it's no big mystery. It's a scripting environment. Like, don't be scared of C++. Just get in there and start, throwing some elbows around. It's fine. You can write it in C with classes style. You don't even need to get terribly OOP or anything with your C++, just because it happens to be. C with classes style is just to write it like C. Treat it like it's C, but it's not. I know it's a pedantic point, but But it has classes. You know, it has all the templating and stuff, the fancy stuff. Drop your dynamic memory. Just don't even do it. Just make a buffer, rewrite the buffer. Don't be subtle about it. Don't use dynamic memory. The companies that make microcontrollers are already doing all that stuff, so you're gonna get in their way. Offload all the thinking you can. Microcontrollers can certainly do plenty of thinking, but just get it out of there. Use it to read input and send output, and be done. UDP is great. Fire and forget. Make that stream. Don't worry about handshaking like with TCP or anything like that. Just go for it. Get comfortable writing like C strings. Like you can use strings if you want, but you're still going to end up needing to debug it as you put your packets together. There's no callbacks or pumping. You just check the pins every loop. It's pretty simple, pretty straightforward. This is my Unity server. It's pretty simple. There's a C# script. It checks for the incoming packets. It decodes them. It searches for keywords, and then it updates the player on screen. Let's talk about going from like a breadboard to soldering. You start with breadboards and jumper cables just to start connecting things. They're really great. To really get things up and going. There's plenty more solderless options that I'm not going to go through too much, but like you might use bullet butt connectors, you might use spade connectors, you might use fork connectors. Those are all solderless options that are pretty quick to put things together with as well. You're going to start moving over to soldered things after a while, after you have kind of finalized where you want things. Soldering is pretty simple. It's the process of applying lead solder to wires and terminals. And then you put some heat shrink on the outside, and you kind of shrink it up, and you're all good to go. Wear your PPE. It's lead solder. Save your lungs. There's some terms like pre-applying solder to both sides is called tinning. And then when you take two tinned edges and like press them together and apply some heat, that's called pan soldering. It's pretty simple. If you want to get really fancy, you can go ahead and look up the NASA specifications for soldering, and they get really specific and kind of fun about like how they want to do their soldering. There's some bit about plugs in here. We'll see some T-plugs when we go over to the batteries. They're really common with batteries, but they're a cheap, easy way to make your components more reusable as you solder them together and make them more permanent. You might there's some alternatives to T-plugs. The XT60 and the J connectors are both very common. An LED is a great place to start. Use it, turn the LED on when the microcontroller's on, turn it off when it's off, and you have yourself a really simple error light to really start disconnecting you from your PC and getting that controller or whatever into your hands. The buttons I chose on this are American-style arcade buttons. They have a nice feel, and I had a bag of them lying around. They gate a path to ground, and when you press the button, it completes the path, and the pin gets struck low. And when you're checking your pins, you're going to check to see if it's low, and if it is, you know that your button is pressed. You need a second to debounce the buttons, but since we're already going to use a 10 millisecond delay for the UDP packets, then that's enough to debounce it. The logic's going to come in inverted because it's pulling low, so as soon as you get it in, flip it. You don't want inverted logic going throughout your system. Just clean it up before you move on. Save yourself a headache. I added a joystick because I thought it'd be kind of fun. I have not actually worked with joysticks in the past. and it was neat to kind of learn a little bit more about their requirements. They need 2 analog pins. This feather board was great because it comes with 12 analog pins. I can put a lot of joysticks on there if I need to. And the joysticks are pretty simple. They just control variable resistors, and like that resistance like adjusts. So you push 3 volts through the joystick, and then you adjust the resistors as you move the joystick, and then send that voltage back out. Microcontroller reads it back in, and you know the difference is what you're looking at. 0 voltage is maximum resistance, and 3 volts is least resistance, and that's your range. And the featherboard will go ahead and break that analog value into digital steps for you. So it'll do the heavy lifting for you on that front. Batteries are a great way to break the whole system off of there, make it really impressive. They're a little scary, but they're not too hard. Lipo batteries are great. You get a battery charger, get some Lipo batteries off of like a RC car like website or something, or that community uses this regularly, so they're great to leverage for knowledge. You need to charge them with a balance charger, but you don't necessarily need to. There's a lot of considerations to take into your head when you get away from the balance charger. Even like really established companies like Samsung and Apple have problems with their batteries sometimes. And that's well, because they're not hooked up to balance chargers. They're hooked up to your phone. They're hooked up to a board. Add a rocker switch. Easy. It's easy. Makes it kind of nice. I split my voltage into like a 5-volt line and a 4-volt line. The board is actually supposed to, the Feather microcontroller should work at 3.3 volts, but it doesn't. That's a bold-faced lie. It starts working at 3.8 volts, and it gets stable at 4 volts. So you just bump it up a little bit. It's fine. Add a voltmeter. This is just the voltmeter just checks your battery level. So it lets me know how drained my battery is. That's it. Okay, that one was much shorter than the previous one, so I hope I didn't rush through it too much. Hope everybody had a good time. This last bit I'm going to run through pretty quick. I've made some other controllers in the past. I just wanted to talk about these each for just a second. This one in the upper left-hand corner is a wheelchair, being controlled by a Magic Leap. So the Magic Leap's the client here, and the wheelchair has become the server, and there's a Raspberry Pi in the mix, and it's accepting those packets and updating everything, and it's all running off batteries and stuff. Moving to the left here is the big orange dance machine. This is a dance installation piece. Most of this work was converting it from being a roadside traffic sign into a programmable LED matrix, while preserving the solar panels and other things that keep it running. This is a Vive controller in the upper right hand corner. If you are interested in custom Vive controllers, please feel free to start a conversation with me about it. In the bottom left-hand corner here, you see this is a knockoff PlayStation Move controller that we made for Starbreeze. They didn't use the PlayStation Move tracking solution. They have their own tracking solution, but they did use it for the reload and the kickback, which are all functional. So that is my first product that went to E3, and it was pretty neat to see it untested. So I'd like to show it off a little bit. It's this controller, if you see in the bottom middle. It's this controller. In the bottom right here is just a solenoid. It's getting controlled by Magic Leap. It's just another really simple controller. My contact is on the bottom for all of this. My email is mrelenbaas@gmail.com. You can find me on Twitter. You can find me on YouTube. You can email me. You can talk to me. You can call me. I'm always I'm always looking for business, always looking for work. If you know anybody that's interested in anything like this. Thanks so much for listening to my presentation.
All right, thank you. That was awesome. It is always so satisfying to see controllers made side by side and, like, you know, being used to play a game in something like a video, or, you know, in person or something like that. Cool. Yeah, digital claps, please. Yeah, that was awesome. That's a lot of really good information, and I think. Oh yeah, I was gonna say, Bradley, if you wanted to share your link again in the chat, that would be awesome. Bradley has some resources on the project that he's working on, and again, as I think I said earlier, and he's kind of implying in the chat as well, if you have questions about some of this stuff, or thoughts on where you want to go for a next project, or sounds like, per the chat, a couple of you maybe need some soldering safety tips to make your soldering journey a little bit easier, make sure to hit him up in the Discord for PIGSquad. He's in there, and sometimes he's streaming the work that he's doing on his controllers in one of our streaming channels, so check that out. And if anybody has any questions at all, please ask. I think there was a lot of good discussion during that talk, but if there's any further questions, please just let us know. Yeah, it's really, really fun to see all of that, because we had a crew of PIGSquad people for a while putting together kind of like their own arcade cabinet, and we got to see a lot of that process of it being built up and finished and everything like that. So, oh my God, yeah, that's a great idea. We should do that at like OMSI. Everybody is talking about how we need to do a learn to solder workshop when we're all back in person. That'd be super great. We'll do it. We'll just like meet on a street corner so that we can, you know, not burn down the house, as we're saying. We'll put our soldering irons down on the concrete, and we'll just run an extension out from a cafe or something. That's how we'll do it, and we'll bring chalk for the kids. That's where our soldering workshop will be. But make sure to bring your PPE. That's what everybody's saying. Make sure to protect yourself. Well, cool. Thank you so much. That was great.